Hello everyone, welcome back. In this video, I will show you how to test for normality in SPSS, and we are going to look at three different methods. The first one is histogram. The second method, which is a statistical method, is Shapiro, and the third one is Kolmogorov. The last two are statistical method, while the first one, which is histogram, is a graphical method. So please sit well and pay close attention. First thing is, what is a normality? Normality can be defined as a condition in which a data set follow a normal distribution, and normal distribution is also referred to as a Gaussian distribution or bell curve. A situation whereby the shape of your data takes the bell shape, or where the mean, the median are equal, is referred to as a normal distribution. So when you have a curve presenting your data like this, a bell shape, something like this, whereby we have the mean, the median, and the mode. At this point, we say the data set is normally distributed. But any deviation from this is what we refer to as non-normality. In that case, we say that your data is not normally distributed. So normality means that your data is shaped like a bell curve, and most values are around the average, and fewer values appear as you move away from the center. You can see that here we have this most value appears around there. We only have fewer values here, fewer values here. You can see the shape of the curve. So when you run the histogram and you have a curve like this, then you can conclude that your data set is normally distributed, or the particular variable you are looking at is normally distributed. And when you notice that the variable is normally distributed, then you can proceed and use a parametric method to analyze the data. Now let us look at the key features of a normal distribution. The first one is symmetry. What do I mean by that? Is that the curve is perfectly symmetrical around the mean. You can see this is a symmetric distribution, and in this case we have the mean, the median, and the mode equal. So when you have something like this, you can say that it is your data set is symmetric. And another attribute is that the mean and the median as well as the mode are equal. All three central measures are equal. So this is what we have here, just the same thing. And the third feature, which you can also mention, is that most of the value clusters around the center. This is the center, and you can see that a large number of the value clusters around there. So these three are the key features, and when you are asked to mention any features of a normal distribution, once you mention any of these, then you have done justice to that question. So please don't forget, symmetric, mean, median, mode are equal, then bell-shaped curve. Then the last thing which I want you to also take note is the 68, 95, 99.7 rules. It is also reversed to as empirical rule, and in such situation we say that the 68% of values lies within the one standard deviation. You can see the standard deviation here. You can see the standard deviation here. So the 68% of the value lies within here, the one standard deviation, this and this. That is -1 and +1. Then 95% lies within the two standard deviation. If you look at the two standard deviation, you can see here this is +2 and -2. So 95% of the value or data set of the data lies between -2 and +2. And the third one is that 99.7% of the values lies within the three standard deviation. This is +3 standard deviation and -3 standard deviation. So this is what we reverse to as empirical rule, or 68, 95, 99.7 rule. So please take notes of all these features. You may want to ask, why do I need to check for normality, or why does normality matter? The first reason, which is very, very important, is that if you want to use a parametric analytical approach, you must ensure that your data set is normally distributed or are normally distributed. And there are some parametric statistical tests such as regression, ANOVA, t-test, and others that assume that this particular condition holds or assumption holds. So if you find that your data set is not normally distributed, and you have to ensure that you use a non-parametric analytical test, because if you report maybe at the beginning of your data analysis that your data is not normally distributed and you go ahead and use a regression method, ANOVA or t-test, what you have done is not, there's no way you can achieve your goal with that particular analysis, because once your reader who is very good in analysis sees it, person will certainly condemn it, or your supervisor. So first, you ensure that you check for linearity. Please, if you don't know how to check for linearity, check the description of this video. We have I've done a video on that, and it's on this particular playlist as well, SPSS playlist. So check out to do linearity test. So once you are done with the linearity test, you proceed to normality test. So once you notice that your data are not normally distributed, or your variables are not normally distributed, then you make use of non-parametric test just to save yourself of failure. If the assumption of normality is violated, this test may produce inaccurate or misleading results. That's just the facts. If your variables are not normally distributed, there's no way you can guess a perfect or accurate results, and whatsoever you come up, whatever policy you come up with at the end of the day will not be taken serious, because your data actually violated the normality assumption. So first thing, linearity, followed by normality test. So those are the two reasons why you must check for normality test before you proceed with your analysis. What are the methods of testing normality in SPSS? We have two major methods, the graphical method and the statistical method. Under the graphical method, we have the histograms as well as the QQ plot. But the fact remains that you can't make your justification or your final decision based on the outcome of the histogram. You need to support your analysis with statistical tests, statistical approach, and you can use either of Shapiro-Wilk or Kolmogorov approach. So let's quickly take a look at the visual method or the histogram approach. What are those things that you need to look at for when you run your histograms? In the histogram, if your data form a roughly bell shape, that is a good sign. It means that your data is normally distributed. And what do I mean by good bell shape? Let me take you back. This is what I'm referring to. So if you run your histogram and you have something like this, then your data set is perfect. It's perfect. But you can't rely on that particular result alone. And for QQ plot, you must ensure that the points are close to the diagonal line. I will show you that when I'm doing the analysis in SPSS. As I've said, visual alone aren't enough, so you must look at the statistical tests. Now, what are the two statistical tests? Shapiro and Kolmogorov. Please take note of this. If your sample size is less than 50, you must stick to Shapiro-Wilk test, or you must report Shapiro-Wilk test. But if you have a larger sample size, 50 upward or 50 plus, then Kolmogorov is appropriate or is suitable. The fact is that SPSS will give you the two results, so it is left for you to choose the right one. But the only criteria for choosing Kolmogorov is that you have over 50 sample size. And if you want to go for Shapiro-Wilk test, then you must ensure that your sample size is less than 50. Now let me quickly run you through how to interpret the two statistical tests. The first thing you need to look out for is the significant value, which can also be reversed to as probability value, but often SPSS reports it as significant value. So if the significance value is greater than 5%, that is 0.05, it means that your data is not significantly different from a normal distribution. In other words, your data is normally distributed. It has a bell shape. So you can use this particular test to affirm the visual method. Once you notice that the graph or your graph, the histogram, has a bell shape, then you proceed to Shapiro or Kolmogorov and check whether the probability value is greater than 5%. If it is greater than 5%, then you confirm or you report that your data is normally distributed. But if you have a contradictory result, for instance, if the graph or the histogram looks like a bell shape, and when you check the probability value of either of the two statistical tests and you notice that it is less than 5%, then you have to stick to the report or the result of the statistical approach. So please don't go for the graphical approach. But if the significant significant value is less than 5%, it simply means that your data are not normally distributed. That's just the conclusion. So what you need to look out for is the significant value. Check if it is greater than or less than 5%. Now you may want to ask, what if my data is not normally distributed? There's nothing to panic about, so you just have to keep cool and look for alternative approach. The first thing is that you can transform your data. You can take the natural log or the square root transformation. But if you don't want to make use of that, then if you are checking for the correlation between two variables, then you can make use of non-parametric tests such as Spearman rank order correlation. Also, you can go for other techniques in case you want to do more advanced analysis. You can make use of Mann-Whitney test, Kruskal-Wallis test, and so many other ones. So make sure you check for linearity, proceed to normality, check if your sample size is less than or greater than 50%, check the visual graph, check the significance value, and make your decision. But you must ensure that you make use of the appropriate techniques of analysis at the end of the day. If your data indicates non-normality, go for non-parametric test. But if it is normal, then you go for parametric approach. So now let me take you through how to run this in SPSS. Okay, so this is my work file, and here I have both categorical variable and continuous variable. In case you don't know the difference between continuous and categorical variable, please check our channel. I've done a video on that. Height here is a continuous variable, income is a continuous variable, and this is the square root of income, natural log of income, weight, and weight before, weight after. So now to do the normality test, you go to analyze. From analyze, you move to descriptive, statistics, then you select explore. Once you click on explore, you will have this particular window opened. Then you can move all your variables from here to the dependent list. All the variables you want to check the normality, you just highlight everything and you move it. So if I want to check for the normality of everything here now, I can just press Ctrl A. It will highlight everything and move it here. You can see strange variables are not allowed. Gender is a strange variable, so that's why strange variable. So let me exclude this, let me exclude ID as well. Then I move others here. So now you go to statistics, then you check in case you want to report outliers. If you want to change the confidence interval for me, then you can change it here, but just maintain this particular setting. Then you click on plot. Once you get here, you tick histogram, then you also tick normality plot with test. But if you don't want to report histogram, or if you don't want to report normality plots, you see these two are the visual approach or the graphical approach. So if you don't want to make use of the visual or graphical approach, you can just untick this and this. But here we are going to tick both because I would love to interpret the result as well. So once you have done that, you click continue. Then you can see display both statistics and plots. So if you want to focus on plots alone, then you can select this. If you want to report statistics, the two, then that is Shapiro and Kolmogorov, then you select it. But if you want to have the results of both statistical tests and graphical tests, then you can click both. So once this is selected, then you click OK. Here is our output window where we have all our results. Okay, now we have our results. Here is our result. This is case summary. You don't need to report this in your analysis. You have no business with it. This is descriptive. Of course, you must have done that. In case you don't know how to do descriptive analysis, please check our channel. Check this SPSS playlist. I've done a video on descriptive analysis. Also, I will put the link in the description of this particular video. You can just check later. But we have to go down because we don't need the descriptive analysis. And don't forget, descriptive is used for continuous variable, while frequency is used for categorical variable. You need to know that as well. I explained everything in the video titled How to Conduct Descriptive Analysis in SPSS. Okay, now this is where you start. You can see test of normality. I told you that you need to first check the graphical approach before proceeding to the statistical approach. So let's go down and check the graphical approach. You can see this is the histogram for height. You can see now this is not a bell shape. You can see this has a long right tail. So you can conclude based on this that height is not normally distributed. Height is not normally distributed. Okay, look at weight. Weight looks like a bell shape. So based on this, we can conclude whether this particular variable is normally distributed or not. We need to go back to the statistical check and confirm. But before we do that, let me take you back to the data set. Let us check the sample size. Here we have above 50 sample size, so we can use Kolmogorov. So now we are not going to look at the significant value of Kolmogorov. And see, this is what we are going to look at because it is our sample size is more than 50. So now let's check height. You can see the probability is less than 5%, and the division rule is that if the probability value is less than 5%, it means that the data is not, or the data yes, the variable is not normally distributed. And look at weight, the one that looks like a bell shape. Look at this is 0.019, pardon me. The probability value is less than 5%. So now if you conclude based on the histogram that the variable is normally distributed and you check this, you will notice that your division will not be valid. So you need to check for the statistical sense. So based on this result, we can say that weight is not normally distributed. Let's check out through. This particular result shows that all the variables are not normally distributed. So if I want to do any analysis, maybe if I want to check for correlation, I want to check for association, or I want to make use of, I want to check for the impact of any of these variable on the other, I must ensure that I use a non-parametric approach. For instance, if I want to check for correlation, now I must use Spearman. If I want to analyze the impact, then I must use a counter regression, which relies the assumptions of normality. Let me take you through the other. Look at this now. This is normality, normal QQ plus of height. And what is the condition here? Let me take you back so that you can see. Check the what it says. The QQ plus should have points close to the diagonal line. Look at the diagonal line here. This point is far from the diagonal line. Also this one. Although these ones, all these points are close, but these ones are. So you can also conclude based on this that height is not normally distributed. So now we have used three methods: the normal histogram approach, the normal QQ plus, as well as the statistical test. So based on those results, we can conclude that height is not normally distributed. Then you do the same for weight. This one looks like a bell shape, but the statistical test shows that the probability value is less than 5%. So we can conclude that it is not normally distributed. Now let us check the QQ plots. Okay, you see that this one stood, all these points are very close to the diagonal line, but this one is far. This one is a bit far too. The same thing is applicable to this and this. So now the three methods suggest that weight, the two, yes, we can say the three methods suggest that weight is not normally distributed. But let me show you something here. If you click on these two eyes, it will take you to the chart editor. So let's fit the line. Let's fit the line. Show label, show interpolation line. Let's show interpolation line. Okay, you can see interpolation line. Okay, let's show distribution curve. Yes, distribution curve is okay. That one will show us. Let me uncheck interpolation like this. Okay, let's stick to the distribution curve. You can see the distribution is, it looks like a bell shape, but the results of the statistical test as well as the QQ plot shows that this, though it is near normal, but it is not normal. Near normal, but it is not normal. So when you want to conclude, you just conclude that the variables are not normally distributed. So you just look the graph. This one too, look at current salary is not normally distributed. Let's look at, you can see this one is very far away from the diagonal line, and the statistical test also has shown that it is not normally distributed. So with this, we have come to the end of this particular tutorial, and I am certain that you can now run a normality test in SPSS. So please subscribe to our channel, like our video, and share with your friends, your colleagues. Thank